Hi everyone, welcome back to my channel. For today's topic, we have differentiates linear inequalities in two variables from linear equations in two variables. Objective number 1, at the end of this lesson, you should be able to differentiate between a linear equation and a linear inequality in two variables. Equations and inequalities are two of the most commonly used terms in mathematics. First, what is equation? An equation is a mathematical sentence which shows that the two quantities have the same or equal values. It uses the equal sign to show this relationship. Next, what is inequality? An inequality, on the other hand, is a mathematical sentence which shows that two quantities may have different or unequal values. It uses the symbols greater than, less than, greater than or equal to, less than or equal to, and not equal to show this relationship. Let us have now the similarities between linear equation and linear inequality in two variables. Both have two variables of degree 1. Both can be graphed on the Cartesian plane. Their solutions can be expressed as an ordered pair xy. What about their differences? They differ in symbol used, standard form, graph, and solution. Now, let us observe the graph of linear equation and linear inequality in two variables. We have 5x plus 2y equals 14 under linear equation, and 5x plus 2y is greater than or equal to 14 under linear inequality. And their graph Next, identify whether each of the given statements is true or false. Number 1. A point is a solution of a linear equation if it is found in the shaded area of the graph. The answer is false. The graph of a linear equation is a line. There is no shaded area. Number 2. The statement y is greater than to 2x minus 1 is a linear inequality. The answer is true. This is a linear inequality written in slope-intercept form. Number 3. The statement 2x minus y squared equals 5 is a linear equation. The answer is false. A linear equation in two variables would have exponents that are equal to 1. Let us have objective number 2. Recognize the graph of a linear inequality in two variables and graph a linear inequality in two variables. In algebra, the graph of an equation is a representation of its solution. The solution of a linear equation in two variables is represented by all the points that are on its line. The same is true with the graph of an inequality. The solution of a linear inequality in two variables is represented by a shaded region or area. This implies that all points on the shaded area are solutions of the inequality. Graphing linear inequalities in two variables. Graphing a linear inequality in two variables builds on your skill of graphing linear equations. The first step in the process is graphing a line using any of the methods you've learned: slope and y-intercept, intercepts, 2 points, or table of values. Note the following in graphing the final line. If the inequality is less than or greater than, use a broken line. If the inequality is less than or equal to or greater than or equal to, use a solid line. The next step in the process is using a test point to determine which side to shade. A test point can be any point on either side of the line graph. Substitute the x and y values of the test point to the inequality. Finally, if the test point is a solution, shade the whole area where the test point is. If it is not a solution, shade the opposite side where the test point is. How to graph linear equation and linear inequalities in two variables. Our given is graph 5x plus 2y greater than or equal 14. Step 1. Graph the line. To do this, change the inequality symbol to an equal sign. So we will have 5x plus 2y equals 14. Graph using intercepts. Find x-intercept. If we are finding for the value of the x-intercept, we have to let the value of y equal to 0. So we will have 5x plus 2 times 0 equals 14. Simplify, we will have 5x equals 14. Then, the value of x is 14 over 5 or approximately 2.8. Take note of the value of your x. Next, find the y-intercept. So if we are going to find the y-intercept, we have to let the value of x equal to 0. Therefore, we have 2y equals 14. 14 divided by 2 is 7. Therefore, y-intercept is 7. Plot the x-intercept 2.8 on the x-axis and the y-intercept 7 on the y-axis. Graph the line by drawing a straight line connecting the 2 points. So this is our graph. Note, the graph of the line is solid because the inequality symbol is greater than or equal. Next, step 2. Determine the shaded area by using a test point. The easiest test point is 0, 0 or the origin. Substitute x equals 0 and y equals 0 from the test point to the inequality. So we have our given 5 times 0 plus 2 times 0 greater than or equal to 14. Simplify, we have 0 is greater than or equal to 14. Since 0 is not greater than or equal to 14, this statement is false. This implies that the side of the line where the origin is found, left side of the line does not contain all the possible solutions of the inequality. Instead, all the possible solutions lie on the straight line of the line. Step 3, we have to shade the area containing the solution. So we will have, now it's your turn. Graph the linear inequality y is greater than 2 over 5x minus 3 or 2/5 x minus 3. Just follow the steps we had. Step 1, graph the line. Step 2, determine the shaded area by using a test point. Step 3, shade the area containing the solution. We will have more examples on my next video, so stay tuned. And thank you for listening. Bye!